Hey everybody, here we are with the answer key for the quadratics practice test. I've written it all out so it'll go faster because I want to keep this pretty short. Here we go. Factoring. Solving by factoring means break it apart, unfoil it. This is easy factoring, not box method worthy. No coefficient in front of the x squared, so you just can write an x and an x. What two numbers multiply to make 20 that add up to make 9? That's 4 and 5. You got to give them that sign, that negative sign. They're both the same when it's plus. If that's a minus, they got to be different. But it isn't, so you don't. Well then, when is each of these separate factors 0? It's the opposite here. Write a little equation and solve it. If you have a number out in front, like a 2x minus 4, you got to solve that. You can't just take a look at that number only and do the opposite. But it's 4 and 5. There we go. Next one, solve by extracting the square root. The key thing here is to identify that there's only one x there. So this is peeling away the layers like the Russian doll. Take away the outermost layer, that's a 1, subtract it from both sides. Take and divide by 3. It goes from 37 down to 36. You divide by 3, you get 12. Then you square root both sides, the square root of 12. I break it apart to see if I can take out any parts of the square root. Turns out there are two 2's, so out comes that perfect pair as a 2. Left behind is the lonely 3. 2 radical 3 is equal to radical 12. So then I go from x minus 2 equals that to adding 2 to both sides. So the final best answer is 2 plus or minus 2 radical 3. There it is in exact form in the answer sheet. When I type it into the calculator very carefully, I get these 2 decimals. I round them to 3 decimal places. Next problem, completing the square. I'm going to try to transform this so that it looks a lot like the problem we did up there. The steps are, first, move any numbers by themselves, any single numbers without x's over. You just want x's on this side, the x squared and the x term. Then make sure there's no coefficient out in front of the x squared. Some of them have it, some of them don't. This one does, so you got to divide everything by 3. We're lucky in that the 12 is divisible by 3. I get 4. We're unlucky that 7 doesn't, but I'm not freaked out. I just write 7 over 3 and I deal with it. Then to complete the square, you always say, hey, what's half of 4? That's 2. When you get that number, you square it, multiply it by itself. So it's the formula is b over 2 squared, and you add that identically to both sides. When I do that, I get 4 on both sides added. That gives me the ability to factor this down. So there it is, written in the squared form that I like so much from the problem up above. I just have to, again, work with these fractions. 4 becomes 12 over 3. That makes the common denominator I need. 7 plus 12 is 19. So it's 19 over 3 when I square root both sides. So my answer, my exact answer is just, when I take away the 2 from both sides, negative 2 plus or minus the square root of that ugly fraction. Just leave it like that. That's exact. That's why this is actually not that hard. You don't have to do a lot of processing. If it works out simply, you want to simplify it, but you don't. So when I put it in the calculator and type it all out carefully, I get that. Onto this side, here we got the quadratic formula. So I identify my a, b, and c. I try to take out a common thing if I can, but I can't. When I plug in my numbers very carefully, I get a negative 7 becoming a positive 7. When you square a negative 7, it's always positive. You should never get a negative there. Then minus 4ac, these two negatives cancel, and that becomes a plus. So it becomes 7 plus or minus 49 plus 240, all over 40 then. 2 times the 20 gives me 40. This happens to be a perfect square. So when I square root it, I get exactly 17. 7 plus 17 over 40 is this, gives me 3/5. 7 minus 17 over 40 is negative 10 over 40. Cancel a 0 and I get 1/4. No decimals there, but if I did, I would just use my calculator and I'd find them. Okay. Solve this using any method. Well, I didn't write an explanation, but I have to expand everything first. I square 2x and I get 4x squared. I distribute in the x and I get x squared plus 4x. I look at both sides and I figure out what to do. I'm always going to go over to the side that has more x squareds. So I'm taking it away from this side and take it away from there. I get 3x squared. Then I take away 4x from both sides, from negative 8 to negative 12. I take away 2 from both sides. That ends up 0. 11 take away 2 is 9. This is something I can factor. I might not notice it if I'm not paying attention. I can take a 3 out of everything, and I would get then x squared minus 4x plus 3. If I didn't recognize that, quad form always works. And I just plug it in, and I grind it out. Okay, this one happens to be a perfect square. They always are when they're factorable. I get 6. 12 plus 6 is 18. Divided by 6 is 3. 12 minus 6 is 6. Divided by 6 is 1. Okay? On to this side. Here is the 5 points of the parabola. We've done this before. There are lots of videos about this. I'm not going to go into it in too much detail, but find the vertex. Minus b over 2a gives me 2. That axis of symmetry is at the x equal 2 line. So it makes sense that I plug in 2 for x. I square it, and I do all the good math, and I get negative 8. That's the vertex down there, 2, negative 8, the lowest point. Then I find my intercept when x equals 0. That's easy. Everything drops off except for the negative 6, so it's 0, negative 6. Well, then I just take and I flip this point over there so that that distance is the same as that distance. That means I just double the 2 to get to 4, and I keep it at that same level, negative 6. These last 2 points are just when I factor it, or I quad form it, or I do whatever and I solve it. If this has got a fraction out in front, I don't worry about it too much. I just double everything. That's called clearing the fractions. If it was a 1/3, I'd multiply everything by 3 to get rid of the fractions. This is something I can factor. When I factor it like before, I get my solutions 2 and 6 and negative 2. Those are the x values. Each time I plug those in, I'll get 0. So that's why it's negative 2 gives me 0 and positive 6 gives me 0. That's where these are. So I can maybe label that that's going to be 5. So that's 6, 0. All right. This word problem. Find the dimensions of a rectangle whose length is 3 units more than its width. Well, there's the width. So the length is 3 units more than that. An area is always just those two sides multiplied. That's like the definition of what it means to multiply practically. So I get w squared plus 3w equals the area of 100. It's a very simple quadratic. When you have the quadratic formula, a, b, and c get plugged in. That negative 100 cancels with that negative. It becomes the square root of 409. And so I want to show you how to type that into the calculator very carefully. You can see that what I'm going to do is, I hope that'll show up. Whoop, don't want to tip my camera off. Yeah, I'm going to just type in, what is it, negative 3, and then plus, and then the square root. So I go second square root, and it's 409, and then I can just hit enter. When I get that, I just go divided by 2. I would say do it in the 2 stages. You'll never go wrong. And that's the answer, and I round it. Okay? So there are my exact answers. On to the calculator page. Actually, most of this you will be able to use your calculator. To find the 1,000th term of a pattern in a quadratics test, it's going to be quadrag. Okay? Whoops, sorry, I chopped that off. To find this pattern, the next term in this pattern, I'm going to use quadrag. So I just go to L1, I type that data in. I go to L2, I type that data in. Then you see here that what I'm going to do is go, here's my stat. There's my data in L1 and L2. You can see that. Then I'm going to go to the stat button again, and I'm going to go over arrow to calculate, and I'm going to choose option number 5, and I'm going to make sure it says L1 and L2. If it doesn't, I can just type, see above the 4s like L4, so I would just change that. Here all I have to do is do enter, 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 and my A, B, and C values pop out. So there we go with A, B, and C, and I just plug it into that quadratic form, not formula, and I get 1,001,004. All right. So here's solve the following equation. It's ugly decimals. You just got to move the 6 over. Use the quadratic formula very, very carefully. Calculators are wonderful like that, and it'll give you that answer. All right. You can also do it by graphing, and I guess that's something that I can show you this time to get the answer. If we go to y equals and hit y equals right there, you'll see that I've got those two equations typed in. If I do zoom 6, I hope it shows up. Okay, I'm seeing a bit of it. I've set the two equations equal to each other. All I have to do really is zoom out. Zoom out is option number 3. It doesn't zoom out until I hit the enter button. So I'm going to hit the enter button right there, and you'll see it zooms out. And I can see that this line going across horizontally is going to intersect my parabola right there and right there. Okay? The way I do this is I go second and then the trace button to calculate. And see that option number 5? If I hit option number 5, whoops, right there, it'll choose intersect. And then I just say first curve, and I can say yep. And then second curve, I say yep, and I hit enter. And that's one intersection point, point 210. And then I do the same thing for the other intersection point. I'd use the arrow to mouse over closer to that. So point 210 is one of my solutions. X is approximately equal to 0.210. And then the other one I'll find in a second and put that on the posted answer. Okay, meanwhile, this one is the distance in feet above the ground of a ball is given by this equation. We can type that in, we can look at the graph, and we can answer the questions. Okay? So I have typed that in already, and it is here under y equals, and what I've got there is two equations are dark with the equal signs there. So what I need to do is I need to mouse over and then down, and when they're dark and I'm on top of it like it is flashing, I can go here and I can just hit enter, and then if I mouse down, you'll see that that equal sign is turned off, so I can do enter again. And if I go down one more time and then hit enter, I will turn on that equation. This way I can type in more equations and do sort of more homework problems without having to delete everything. There's my graph. Now here I've zoomed out on it, so I'm going to do a zoom box to zoom in on it. See, option number 1 is box. So I will say sure, enter, and I'm going to draw a box around that interesting bit in the middle. So if I hit enter, it's hard to see, but I'm taking and dragging over the cursor, and I'm going up arrow, and I'm opening up a box around the part that looks interesting, and then when I hit enter, it'll expand to fill that selected area. So there's my graph. All right, I can look at the window and I can change the window if I want. If I want to see slightly more in the x direction, I maybe will take 3.4 and make it 4, and then my graph will go up a little bit higher. Okay, oops, maybe not enough. I'll hit that window. Oops, not the x, I want to change the y. That's silly. I want to make the y bigger, so I'll make that 20. The vertical is always the y. All right, so I answer questions such as, at the moment is ball thrown at t equals 0, what is the height of the ball? Well, that's just going to be 6. That's the height of the ball when x is equal to 0. How many seconds will it take for the ball to go up and then drop to the same height it was thrown? So it's going to go up and then down. Actually, let me sketch what that graph looks like on this. It's going to be starting at 6 and then going up and then coming down. And so we're saying, well, when does it get over here to be right at that level? All right. So to do that, all I need to do is hit the trace button and then just arrow over until the y value is at 6. So it's not going to be perfect. 5.8 is pretty good. That looks like it's about 1.75. All right. So that's when time at 1.75 seconds. Okay. How many seconds will it take for the ball to hit the ground? Well, I'm just going to do the same thing. I'm going to trace over here till I get to the ground. And if I keep tracing, see when y says 0, okay, there it's negative 1.9, so it's jumping too much. If I go back one, I go up. So a better way to do this is to do second and trace. Get to the calculate menu and then choose option number 2. Go down and then select 0. And I just want to be on the left hand side. I'm above the 0, so I hit enter. Then I'm going to go make sure it's on the right hand side, which is when it gets to negative. And it's definitely negative. I hit enter, and then I go, and that's at 1.94. That e to the minus 12 just means it's a decimal 0.000 with 12 zeros. So 1.94. All right. 1.94 seconds. And what is the maximum height of the ball? I'm going to trace and I'm going to find right there. And then